we are going to cover many things in this section. We're going to cover as many as possible. I believe you are ready for me. Let's start. What is probability? Probability is basically concerned with drawing, there's a space between these two, okay? Conclusion or inference from occurrence or experiment involving uncertainty, okay? If you want to draw inference or conclusion as a result of what? An occurrence or experiment you are made looking at an uncertainty that is coming. Statement like, you will probably score high. Why would you say somebody will probably score high? Why would you make such a statement? Because you have observed the situation, you have observed the preparedness of that person, okay? There is 40% chance you will finish the work. It's because of the knowledge you have that you are making this type of what? Probabilistic what statement. That is a probable statement. There is 40% chance you will finish the work. These are what? Probability statements. So, in essence, probability is a measure of likelihood of a particular event, okay, occurring, expressed as a number between 0 and 1, or between 0% and 100%, okay? A probability of 0 means the event is impossible. That is, the event will not happen. Okay? For instance, in the next 1 second, this pen will fall from my hand. Did not fall. I can say the probability that this pen will fall from my hand in the next 1 second is 0. That means I am very sure, 100% sure that it's not going to happen. Impossible. Therefore, it is 0. If I say the probability is 1, that means it will fall. Okay? That is, you are set. So, a probability of 1 means that the event is certain. There's nothing that will change the event. Okay? Let's look at some instances. Tossing a fair coin. If you toss a fair coin, there are 2 possible outcomes. Either you have a head or a tail. Okay? The head has 50% chance. The tail has 50% chance. It's 50-50. We don't know if the head will appear or the tail is what will appear. We don't know. So it's 50-50 chance. Okay? So the likelihood of these two are equal. Okay? Because the total is 2, we say you have 1/2. You two, you have 1/2 chance of what? Of occurring. Okay? So as you can see in this play, therefore the probability of getting heads is 1/2, that is 50%, and the probability of getting a tail is 1/2. As you can see, each outcome is equally likely. Okay? Another instance is rolling a first 6-sided die. How many sides? 6. Okay? When you roll a first 6-sided die, there are 6 possible outcomes. Either you have 1, or 2, or 3, or 4, or 5, or 6. Okay? Next, each outcome is equally likely. That is, the possibility is equal among the 6 sides. Therefore, the probability of rolling a specific number, such as 3, is 1/6, because each of them has a chance of occurring. How many of them? 6. So, each of them has possibility of 1/6. That is, the probability of 1/6. Another one is drawing a card from a standard deck of 52 playing cards. In a standard deck of 52 play cards, there are 30 cards of each suit. Okay? Heart, diamond, club, and spades. If you want to find the probability of drawing a heart, you will divide the number of hearts, which is 13, by the total number of cards, which is 52. This gives a probability of 13/52, which if you reduce, you have 1/4. Okay? The next thing we're going to consider now is basic probability terms. There are terms you should get yourself familiar with. Please know that we are simply laying the foundation. We are going to look at a lot of questions and we're going to solve all of them. So please make sure you are following. The first one is experiment. Experiment is a very important term you need to know. What is an experiment? The process through which outcomes are generated. The process through which outcomes are generated. A procedure that produces a well-defined outcome, such as rolling a die or tossing a coin. When you toss a coin, that is an experiment. That experiment is going to give you an outcome. So the process of getting an outcome is called what? Experiment. Another important term is the outcome we just talked about. The outcome you get when you throw a die refers to a specific result, okay, that can occur in an experiment. For example, when rolling a first six-sided die, the possible outcomes are the numbers 1, 2, 3, 4, 5, and 6. These are the possible outcomes. Okay? Each outcome has a certain probability of occurring depending on the rules of the experiment or event. For example, the possible outcome of throwing a coin is head or tail. These are the possible outcomes. We also have sample space. Sample space refers to the set of all possible outcomes of an experiment. It is usually denoted by the letter X or omega. Okay? All the possible outcome, all the likelihood, all the expectation, the set of all of them. When you arrange them in a set format, that is what? Sample space. In the case of rolling a six-sided die, the sample space are all these possible outcomes, all the likelihoods. Okay? The set of all the possible outcome of an experiment. For instance, tossing a coin. This is how to represent them. That is the set of all the sample space is head or tail. The tossing of two coins. As I said, you can use S or you use omega. If you toss two coins, you will either have head, tail, tail. These are all the possible outcomes. This is referred to as what? Sample space. The launching of a missile from a submarine. What do you think will happen? Either there is a success or there is a failure. So you can see, either we have success or failure. This is what? The sample space, which can also be represented by the omega, as you are seeing in this place. Okay? The next thing we need to know is event. Another important term you need to understand very well is what? Event. A specific occurrence like rolling an even number. When you roll a fair die, you might get an even number. Drawing a ball of a particular color is also what? An event. You are doing an experiment. You are expecting something to happen. The specific one that will happen. This is a coin you threw. After you threw the coin, you were expecting either head or tail. But this time, head appeared. The head that appeared in that experiment is the event that occurred. You launched a submarine missile, and there was a success. The success that occurred is the event, or the failure that occurred is the event. At the end of the day, what happened? You were driving to the office. That is an experiment on your car. The car might arrive or carry you to your destination, or it might break down along the way. If it breaks down, that is the event. If it carry you to the office, it is an event. What really happened at the end of the experiment? That's called what? An event. Okay? Tossing not two coins, for instance. This is the sample space. The event that head appears on the first coin, these are the event for the first coin. Either head or head tail. But if at the end of the day now, you find out it's head, that is also an event. Okay? So, Event is a subset of the sample space. Because if this is a sample space and this is what occurred, this is a subset of this sample space. Okay, that is, the event can only be taken from the sample space, all the possible outcomes. The next thing we need to do now is to look at the general formula of probability. The general formula. The general formula is the probability of an event or of that event. It is the number of required outcomes all over the number of all possible outcomes. For instance, I say I have this white ball and this triangle, 3 of them. Altogether, we have 5 here, okay? What is the probability that we are going to have the ball? How many balls? There are 2 balls. Required outcomes. 2 balls. All possibility. If you put your hand to draw, if it is ball, don't just say it's 1 ball now. I only pick 1 ball. No, you do not pick only 1 ball. The 1 ball you collected represent all the ball in that box or in the bag. That is 2. All over all the what object in the bag. That is all over 5. This is the probability that what you are going to what take out a ball. If it is a triangle, it is 3 over 5. This is what we mean by what? Require outcomes. All over possible outcomes. A ball is drawn randomly from a bag containing 8 red, 4 blue, and 2 green identical balls. Okay? Find the probability that the ball drawn is not red. Is not red. Is not red. Okay? Now, let's look at this. We have 8 red plus 4 blue plus what? 2 green. That is altogether 14 balls. This is red. These 2 are the non-red. That is 6 altogether. So, the probability that it is not red is 6 all over the total. Okay? That will give us 3 over 7. This is the probability that it is, or let's say, not red. Okay? This P represents probability of whatever you are looking at. Okay? The probability that Peter passes a mathematics test is P. Okay? That is the first information. And he passes English test is Q. Find the probability that he passes the mathematics test and fail the English test. Okay? Now, we have said that probability of success plus failure is equal to 1. Okay? So probability that something will happen, let's say success, plus the probability of failure is equal to 1. Now, we have this question saying, we should find the probability that it passes maths and fail English. Let's concentrate on maths. So for mathematics, there are 2 things, pass or fail. Okay? For English, there are 2 possibilities, pass or fail. Okay? The question says, probability of passing maths is P. Okay? Probability of passing English is Q. I'm going to put P here. I'm going to put Q here. That is a passing. Find the probability that it passes maths, which is P, given to us, and fail English. Q is the success. The failure now is 1 minus Q. That is, here we are saying passing plus failure is equal to 1. Okay? Failure is equal to 1 minus P. That is the first one. The same thing goes that what? Q plus failure is equal to 1. Failure is equal to 1 minus Q. That's what we are getting here. This is the probability of failing English. This is the probability of passing maths. The probability of failing maths is 1 minus P. You must know all this. If you have attended the class on combinatory, I've said that when you see and, even in set theory, it's multiplication or is plus. Here they are saying and. So therefore, the probability of passing, let's say maths, and failing, say English, is equal to passing maths, which is P, and that is times failing English, which is 1 minus Q. This is equal to P minus PQ. Hope you understand this. 50 balls in a bag are made up of red and blue balls. If 6 of the balls are red, how many red balls must be added to the bag so that the probability of the red balls will be 2/3? Listen very well. The first statement here, if you want to calculate the probability of red, is 6/15. That is the probability of red. Is what? 6/15. We are told that there is a new probability, and that probability involves us to add S red to this one. So the new probability, let's call it this new probability, is equal to 6 plus X red all over S red. Remember, total 15. Out of the 15, we have 6 red. The other ones are blue. Now, we are required to increase the number of red. If you put the S red, assume 5 red, it will increase the total of the birds. Those 5 red you put, assume they are 5. They will make everything to be 20. If you are now asked how many red are now in the bag, you will say they are what? 11. So that's what we are doing here. So if you follow this method of all red now, all the red, that is the new number of reds over everything in the bag, that is where you have this probability. All you need to do now is to cross multiply. You're going to have 3, 6 plus x equals to 2, 15 plus x. This will give us 18, 3x equals to 30 plus 2x. Okay? Then we move this to this side to have 3s minus 2s equals to 30 minus 18s equals to 12. This says, let P be the probability of set X. That is set S. Where S are all these, that is with all these elements. Okay? This should have been calibrates. Find probability of A if that of B is 1/4, that of C is 1/5, and that of D is 1/6. Listen very well. The axiom that the sum of all probability is equals to 1 must be applied on this. That is to say, the probability of X is equal to the probability of A plus the probability of B plus the probability of C plus the probability of D. Okay? That of S is given to us as P. This of A is what we are looking for. The B is 1/4. The C is 1/5. Why the D is 1/6. Okay? And you will agree with me that the sum of every probability inside this place is equal to 1. Therefore, we can replace this one with 1. Okay? Therefore, we are going to first of all Say this, we move every other thing to the left hand side. Okay? Let's find the LCM of this. Let's use 60. Okay? This will be 60. This will be minus 15, minus 12, minus 10. Okay? This will give us 37 over 60. And this will give us 23 over 60. So the probability of A is equals to 23 over 60. Okay? If a perfect die is cast, what is the probability of obtaining 5? If I were you, I will pause the video, attempt the question, then you continue and let's look at what? The solutions together. Okay? I believe you have done that. Let's continue. How many possibility, potential outcome? 6. 6 altogether. For you to have 5 is 1 out of the 6. So the probability of obtaining 5 is 1 over 6. Okay? A bar contains 9 identical balls. This comma is not here. Okay? Out of which 3 are blue. 2 are white and the remaining are red. Let's look at that. 9 altogether, 3 blue plus 2 white and the remaining are red. That is, we have 4 that are remaining that are red. If a ball is drawn from the bag, what is the probability that it is blue? Okay, altogether we have 9. For the blue group, is 3 that's representing the blue group. That is a 3 that will go into battle with the rest. You can't use 1. Some people are always confused. Oh, because they are saying if a ball, A1, I will use 1. No. You will use everybody, everything that represents that group. This particular one you draw belongs to. If a ball is drawn from the bag, what is the probability that it's blue? So the group of blue, 3 altogether, we have 9, which is equal to 1 over 3. The second one says, not red. Not red. The not red are this group. These are the not red. They are 5 in number. This is the group that will represent this fight against the red. Going to say 5 over the total. That is 9. Okay? Another way you can approach this is to first of all find the probability that they are red. That is 4 over 9. Then this is the probability that they are red. The probability that they are not red is 1 minus this, because success plus failure is equal to 1. This is success. To get the failure, we remove success from 1 to have the failure. If you subtract this now, you agree with me, you're going to have 5 over 9. The same thing we had in this place. Okay? What is the probability of throwing an odd number with a fair die? A fair die. A fair die. We have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The odd are this. These are the odd. 3. So the 3 odd will come and represent the group of odd. Although we are saying an odd. Out of the odd, we don't know the one that will be selected or that will be shown to us. We throw it. It could be 1, it could be 3, it could be 5. Because we don't know the one that will actually occur, we need all of you to come into this fight. 3 of them, but all together 6. That is 1 over 2. If today is Tuesday, what is the probability that the next day will be Wednesday? Think of it. Think of it. Today is Tuesday. Today. What follows Tuesday? is Wednesday. It is 100% sure. Unless you have to destroy the earth, create your own planet, and rename the days. So the probability that tomorrow will be Wednesday is equal to 1. Because today is what? Tuesday. Okay? In a deck of 52 playing cards, what is the probability of drawing an ace? How many aces do we have in playing cards like this? We always have 4. But we know that it's 1 that we want to draw. 1, just 1. But 1 will not stand alone. If you are ace, you must appear here. Let's count you. Because there is a fight for you guys to fight. And there are 4. Therefore, the probability of drawing an ace is equals to 4 over 52. Which is equals to 1 over 13. A jar contains 5 red, 3 green, and 2 blue marbles. What is the probability of randomly picking a green marble? All the green should come out. Let's fight. Okay? The green guys against everything. That is 8, 10. The probability that is going to be green. This is another question. A die is rolled twice. Twice. A die. 1. After you roll it, do the calculation you want to calculate. And you do it again. Twice. Because they are not 2. It's just 1. You throw. When you finish, what is the probability of getting a 6 on the first roll? You roll it. An even number on the second roll. Now, remember we have this as the possible outcome. 1, 2, 3, 4, 5, 6. The first one, this is what we had. 6, only one side. That is 1 over 6. That is the probability for the first one. For the second one, even number. 1, 2, 3, 4, 5, 6. These are the even numbers. There are 3 in numbers. 3 over 6. Remember, it says the probability of getting a 6 on the first. And this and is saying it's going to be multiplication. Therefore, the probability that the first will be 6 and second, okay, will be even is equal to 1 over 6 multiplied by 3 over 6, which is actually 1 over 2. So 1 over 2, okay, which is equal to 1 over 12. Okay? Pause the video and solve this question before you look at the solution. It says, in a class of 25 students, 12 are girls and 30 are boys. If a student is chosen at random, what is the probability that the student is a girl? The probability that what? The student is a girl. Let's see. Altogether 25. We are looking at probability of getting what? A girl. All the girls must come out versus everything or everybody. This is the answer. In this class, let's look at theoretical probability. What is it all about? Let's see. Theoretical probability is the probability calculated without any experiment being performed. No experiment. Okay? We use the information that is known about the physical situation to do the calculation. Theoretical probability is often used to make predictions about the likelihood of an event occurring in situations where it is difficult or impossible to collect empirical data. Okay? Look at this question. It says 2 numbers are chosen at random from 2, 4, and 7. Okay? Find the probability that the product of the two is even. As you can see, 2, 3, and 4. We are choosing 2 at random. So when you choose 2, for instance, you choose 2 and 4. If you multiply them, what do you have? If you choose 2 and 7, when you multiply them, is it even? This is what we are asked to find. To do this, you do a table by putting 2, 4, and 7, 2, 4, and 7. Okay? Okay? Now you do a multiplication. This multiplied by this is 4, 8, 14. This is 8, 16, 28. Okay? This is 14, 28, 49. Now, let's look at the even. This is even, 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 even. These are the even where you what? Where you multiply the selected or the choosing random two numbers from this. Altogether, they are what? 9. They are 9 altogether. That is 3 multiplied by 3. 1, 2, 3 multiplied by 1, 2, 3. That is 3 multiplied by 3 equals to 9. If you want to count manually, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the probability that it is even is equal to 8 over 9. Okay? Let's look at this question. It says, find the probability that a number selected at random from 31 to 49 is a multiple of 7. To get the total numbers that are involved from 31 to 49 is 49 minus 31 plus 1. Okay? That is 18 plus 1, which is equal to 19. If you count this now, you're going to have 19. From 31 to 49, there are 19 numbers. Okay? Now, if you look at this, if you say 7 times 5, you have 35. You come down. 7 times 4 is 28. That is below this. So 7 times 5 is the first value. 7 times 5, that is 35. It's above this. 7 times 6, that is 42. See above this, but below 49. 7 times 7 is 49. That is the end. These are the multiples of what? 7 between this. Okay? That means we have 3 over the total 19. This is the answer. If 3 fair coins are tossed once, what is the probability that at least 2 heads are shown? At least 2 heads are shown. Going to do coin 1, coin 2, coin 2, coin 3. Okay? And you agree with me, each coin has 2 sides. And there are 3 coins. That is, 2 sides raised to power 3 equals to 2 multiplied by 2 multiplied by 2, which is equals to 8. So we're going to have 8 rows. 1, 2, 3, 4, 5, 6, 7, 8. So what I'm going to do now is add. T, 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 T. Add, T, T, add, T, T. Add, T, add, till, add, T, add, T. Okay? Now, what is the question? If 3 coins are tossed once, what is the probability that at least 2 heads shown? Listen very well. What is the meaning of at least? At least. It should not be below 2, but it can be above 2. The minimum we want is 2. 2 head. But it can be 3 head, 4 head, 5 heads. So this first one, we have 3 heads. That is okay. This 2 heads is okay. This 2 heads is okay. This no 2 head. This 2 heads okay. No 2 head, no 2 head, no 2 head. That is 1, 2, 3, 4. It means the probability is 4/8, which is 1/2. So this is the answer. Look at this question. It says 2 fair dice are tossed. What is the probability of getting a total of 9 or more? Okay? 2 fair dice. A die has 6 sides. 1, 2, 3, 4, 5, 6. So we have 2. Gonna put 1 here. 2, 3, 4, 5, 6. Then we put the same thing. Okay, let's just first of all do for this. That is, okay, we need to add them together. 1, 2, 3, 4, 5, 6. Okay. Okay. Now, we're going to add them. This is 2. That is this plus this 2. This plus this 3. This plus this 4, 5, 6, 7. 2 plus this is 3. This is 4, 5, 6, 7, 8. And so on and so forth. And the question says the minimum is 9 or above. We are looking at this group. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is 10. All together, how many are there? That is 6 multiplied by 6. That is 36. Okay, this is 5. This is what? 18. It means the answer is 5/18. The probability of getting a total of 9 or more. Let's look at it. It says a coin and a die are tossed up together once. What is the probability of getting a tail and a number less than 4? Okay, what we need to do, we're going to put here die. We're going to put here coin. Okay, here for die, we have how many? We have 6. 1, 2, 3, 4, 5, 6. Okay, then for this coin, you agree with me, we have head, tail. That is just 2 for this coin. So now we just, okay, this means head 1, head 2, head 3, head 4, head 5, head 6. Tail 1, tail 2, tail 3, tail 4, tail 5, tail 6. Okay? Now, probability of getting a tail and number less than 4. What are the number less than 4? These are the numbers less than 4. And they are all with what? They are all with tails. That is 3. And all together we have how many? 6 multiplied by 2, that is 12. You count manually, you're going to have 12. That is 3/12. So the probability is 3/12, which is equal to 1/4. That is the answer, okay? This one says 3 fair coins are tossed once. The probability of getting at least 2 tails is what? 2 tails. We are looking at 3 coins. I think we had a similar question like this today, okay? This question, similar question, okay? No need to redraw again. Let's just wipe this. We are going to use this for that. But the questions is asking us to do what? It's saying at least 2 tails, at least 2 tails. Put that at the back of your mind, at least 2 tails, at least 2 tails. This was at least 2 head, but this time is at least 2 tails. tails. We are looking at tails. Okay? Let's also remove this so that we can concentrate on at least 2 tails. It can be more than 2 tails. This is 3 tails. That is okay. 2 tails. 2 tails. 2 tails. Still 4 over what? Over 8. Okay? It's still 4 over 8. Okay? What is the probability of rolling a sum of 5 when rolling 2 fair 6-sided dice? Sum of 5. We had 2 dice today. That is 2 dice. Okay? We're going to use this one. But this time a sum of 5. Sum of 5 is this group. One, 2, 3, 4. That is 4 over 36. 4 over 36. This one, this 9. That is 1 over 9. Okay? A first 6-sided die is rolled twice. What is the probability of rolling a 4 on the first roll and an odd number on the second roll? Okay? What we're going to do, we're going to write down the 6 sides. Draw these vertical lines. Okay? One thing you must put at the back of your mind this time is we are not going to do multiplication or do addition. No. It's simply writing everything the way it is because we just roll. Nobody asks us for addition or multiplication, whatever. So simply put here now. Here is 1. For this, I'm going to put 1, 1, 1, 1, 1. Then I put this second one. This 2, 3, 4, 5, 6. This 2. Okay? The question says 4 and an odd number. 4 and an odd number. We concentrate first of all on this 4. This is 4 at odd number. This even 4 at odd number. This even 4 at odd number. Okay? Then we go for this vertical line of 4. 4 at odd number. 4 at odd number. 4 at odd number. 1, 2, 3, 4, 5, 6. 6 over 36. 6 over 36. This is 1. This is 6. That is equals to 1 over 6. Okay? But if you look at what we have done, there's issue. I don't want to remove this. I want to make it available for you so that you can compare. Look at it. There's issue. What is the issue? We are not following the question. The question says 4 on the first rule. First rule. And an odd on the second rule. Not either way or both ways. This is both ways. Whether first, second, doesn't matter. This is what we have done. But he said the first. Now, it depends on you to decide if you are going to use this for the first rule and this for the second rule. Or you use this for the first and use it for the second. So what I'm going to do, I will call this one the first coin we wrote. This is the second. So for the first is where we are looking at 4. The first. This is the first. And if you look at it, this first one is the one we are writing 2, 2, 2, 2, 3, 3, 3, 3, 4, 4, 4, 4. Okay? So that means we are going to come to this line that has 4. Then, for the second one, we are looking at odd, which is this, this, and this. So it's 3 over 36. Unless they said either ways, whether the first or second, but they only said the first and odd on the second. 1, 2, 3. It's 1, 2, 3. That is this, this, and this. But this one we have done is what? Either way. So 3 over 36, which is equals to 1 over 12. This is the answer. This is the answer. This is in that way. This is not the answer. But I'm leaving it for you to check it out to understand better. Okay, because understanding the question is very important. Okay, the first attempt was simply try both ways. This is what the right answer. Okay, a fair 8-sided die is rolled twice. What is the probability of rolling an even number on the first roll and the multiple of 3 on the second roll? This is similar to the other question, the previous question, this one. But this time we have 8. Okay, therefore we're going to do 8 sides. Okay, let me just use this to demarcate them. Okay, now let's start. Let's call this one the first die. This is the second die. I'm going to write this one first. 1, 1, 1. Okay, let me just write everything. Okay, now let's look at this. The question says, what is the probability of rolling an even on the first? Even or the first? Even on the first. This is even. This is even because I'm looking at the first. Even, even. The next one is the multiple of 3 on the second. What are the multiple of 3? Multiple of 3 are 3, 6, 9. So 9 is not here. So we are looking at this 3, this. Okay, that is 3 and 6. We are going to look at their intercept. Their intercept are this, this another intercept, this another intercept, this another intercept. For this, on this one, this intercept, 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 intercept. Okay? Even multiple of 3 on the second one. Okay? With this now, all we need to do, after selecting this, is to count. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 altogether. How many do we have here? We have 8 by 8. That is 64, okay? Over 64. 8 here, 1, 8 here, 8. That is 1 over 8. Okay? In this class, I'm going to look at empirical probability. Okay? What is empirical probability? So you can see, empirical probability, also known as experimental probability. Remember, we had theoretical probability, the one that involves you not doing any experiment. With this empirical probability, experiment is what? Involved. That's why we are saying, also known as experimental probability or relative frequency, is a probability calculated based on observed data, that is experiment, from an experiment or real world events. Okay? It is the ratio of the number of times a particular outcome occurs to the total number of trials or observation. So if I write this now, the probability of E is equals to the number of times the event occurred all over total frequency. Okay? Empirical probability is often used when it is difficult or impossible to calculate the theoretical probability of an event, or when the theoretical probability does not match the actual result. Empirical probability can be a useful tool for predicting future outcomes based on past data. But it is important to keep in mind that it is based on limited set of observation and may not always be accurate. Okay? This is just to explain to us empirical probability. A coin is flipped 200 times. That is an experiment. Okay? And it lands heads up 115 times. 115 times. What is the probability? That is, what is the empirical probability of getting heads? Okay? So to work on this now, we have 115 all over 200. Okay? That is the probability of heads. 5 here, we have 2, that is 23, that is 40. 23 over 40. Okay? In a survey of 500 people, 280 says they prefer tea over coffee. What is the probability that a person choosing at random prefer tea? Those who prefer tea are what? Are 280 over coffee. So the probability of those that prefer tea is equals to 280 over 500, which is 14 over 25. Okay? A die is rolled 150 times and lands on the number 6 30 times. What is the probability of a 6 in this experiment? The probability of rolling a 6 is simply equals to 30 over 150. Okay? A basketball player makes 65 out of 100 free throw attempt. What is the probability? That is, what is the empirical probability of the player making a free throw? The same thing. 65 over 100 for the probability of what? Free throw. Okay? Which will give us 13 over 20. Okay? Let's look at this. A bag contains 40 red marbles, 20 blue marbles, and 10 yellow marbles. You draw 30 marbles at random and find that 16 are red, 9 are blue, and 7 are yellow. What is the empirical? Let me put that. Empirical probability of drawing a red marble. We are also going to find the theoretical probability. Okay? Two things I want us to find in this place so that you understand something. Before we continue, let's first of all find the theoretical probability. Altogether, how many red? 40 red. Okay? Because this one does not involve any experiment. How many marbles altogether? 40 plus 20 plus 10 together, that is 70. So this is the theoretical probability of what? Of drawing red from this bag. Because this one is just theoretical. No actual experiment is performed. Now look at this. For this empirical one, we are going to look at 30 marbles were drawn randomly. Experiment was performed on 30 marbles. 30. So the total in this case is 30. But out of the 30, 16 were red. You get it? So this is empirical for red marbles. This is theoretical for red marbles. This will give us 8. This will give us 15. It means the answer is 8 over 15 for the empirical probability of drawing what? Of drawing red marbles. Why this is what? The theoretical probability of drawing red marbles. Hope you understand the difference. The actual, the drawing, we know there are 70 marbles in the bag, but not all of them were used. We are looking at the ones that were used. Okay? Out of 200 students, 80 students own a bike. What is the probability that a student choosing at random holds a bike? Very straightforward. 80 over 200. That is 2 over 5. Okay? A spanner is spun 50 times and it lands on the green section 10 times. What is the probability of landing on the green section? This is straightforward. 1 over 5. Okay? Out of 300 emails received, 90 emails are spam. What is the probability of receiving a spam email? Okay? 3 over 10. In a batch of 120 light bulbs, 50 are found to be defective. What is the probability of a light bulb being defective? Okay? A survey of 100 people asked which type of pet they prefer. The table below shows the results. What is the probability that a person choosing at random prefers a cat? Okay? This one, the probability that you're going to prefer a cat is equal to how many cats altogether. So what is the total frequency? That is the addition of everything. 35 plus 45 plus 15 plus 5. Okay? That is 35 all over. This is 80, 95, 100. 5 here, 7, 5 here is 20. That is 7 over 20. In a game, players can win various amount of points. The table below shows the distribution of point 1 in 50 games. What is the probability of winning 20 points in a game? 20 points belongs to 20 in this number of what? Games. All over the sum of all the games, and we are told is already 50. You can see add them to confirm. You agree with me that if you add all this together, you're going to have 50. Okay? Look at this. The table below shows the number of students who receive different letters grade in a class. What is the probability that a student choosing at random receive a B? A B. That is 30. All over 25 plus 30 plus 15 plus 20 plus 10. That is the probability that is going to be what? A B. Okay? This is equal to 30 over, if you add this together, you have 100. If you want to simplify this further, 0.3. The table below shows the number of accidents in a factory over a year by cause. What is the probability that a randomly selected accident was caused by a faulty equipment? Faulty equipment, 25. If you add all this together now, you agree with me, you're going to have 100. Probability of faulty equipment. This here 1, this here 4. That is 1 over 4. If you want to simplify further, 0.25. Okay? Look at this. It says a company's customer service department recorded the number of calls received in a week for different reasons. The table below shows the distribution. What is the probability that a randomly selected call is about a billing issue? Okay? Billing issue. That is 120 all over the addition of everything here. This and this is 200, 300, 350. Okay, this and this will cancel. Agree with me, at the end of the day, you have 12 over 35. Okay? The table below shows the frequency of different colors of cars parked in a parking lot. What is the probability that a randomly selected car is red? It's red. That is, you are going to be red is equals to 35 over the total. This plus this will give us 80, plus 60 will give us 140, plus this will give us 180. Okay, so this is 7. This is, that is 5 here 7, 5 here 36. Therefore, the answer is what? 7 over 36. The table below shows the frequency of different types of books in a small library. What is the probability that a randomly selected book is mystery? That is 90. That is 90 over the addition of everything here. This and this will give us 210, plus this 310, plus this 400. Okay, that is over 400. That is 9 over 40. Can divide further to have the answer in decimal. A survey has 120 people about their favorite season. The table below shows the frequency of responses. What is the probability that a randomly selected person prefers spring? That is 30 over the total in this place. This is 70, this 105, this 120. Okay? A box contains 80 chocolates of different flavors. The table below shows the frequency of each flavor. What is the probability that a randomly selected chocolate is mint flavored? As you can see on the board, the mint flavored is 20. Okay, what is the total? 20 plus 25 plus 15 plus 20 is 80. It means 20 divided by 80. If you divide this now, you're going to have 1 over 4. So 1 over 4 is the answer, okay? A box contains 80 chocolates of different flavors. The table below shows the frequency of each flavor. What is the probability that a randomly selected chocolate is mint flavored? That is 20. If you add all this together, you're going to have 80. Okay? Let's look at this. It says, so families were measured by the number of children they have. The following table is their answers. Calculate the probability that another family of this type will have 2 children, 3 or more children, less than 2 children. The first thing we need to do is to calculate the total, which is, if you add all this together now, you're going to have 74. Okay? The first one, exactly 2. That is 22. So it means that the probability that is going to be 2, exactly 2, is equals to 22 over 74. You can simplify this to get the final answer. I don't want to waste our time here. The next one is the probability that it's going to be 3 or more. Okay, this equals to 3 or more. That is from here down. We are looking at all this. That is 8 plus 2 plus 2 all over 74, which is equals to 12 over 74. Okay? You can simplify all this to get the final answer. Less than 2. Less than 2, that is anything below 2. That is this and this. We are looking at what? The probability that is less than, okay, let me put it like this, less than 2 is equals to 12 plus 28 all over 74, which is equal to 40 over 74. Can simplify more to get the final answer, okay? It says a die is tossed 100 times and the results are recorded in the table below. Calculate the probability of obtaining a prime number. Remember, prime number starts from 2 because 1 is not a prime number. These are prime number. Prime numbers are numbers that can divide themselves, and also 2 can also divide them. This one can divide itself, but 2 cannot divide it, okay? Find this now, that is, the addition of everything here is 100. So we are going to use these values, okay? That is, the probability that is going to be prime is equals to 19 plus 24 plus 12. Sorry, plus 22 all over 100. This equals to 65 over 100. That is 13 over 20. Okay? The table below shows the number of goals scored by 32 football teams in a World Cup tournament. Find the probability that if a team is choosing at random, that is scored at most 4 goals. At most 4 goals. So please, sorry, this is number of goals, not dice. Okay? So the first thing we need to do now is to look at this. That is the summation of this. Going to have 32. Okay? Now, at most 4. That is the highest. Here to this place. That's going to look at these values. Okay? At most 4. Cannot be above 4. But it can be below 4. So that is probability that is going to be at most 4 is equals to 4 plus 1 plus 8 plus 7 all over 32, which is equals to 20 over 32. That is 5 over 8. Okay? Look at this. It says the age of some pupils are given in the table below. What is the probability that a pupil choosing at random is not 8 years? We don't want this out of it. Okay? So we're going to deal with this and this. That is using these two values. But before that, we need to first of all find the summation of everything. That is 5 plus 9 plus 7. That will give us 21. Okay? So, the probability that it's not 8 is equals to 5 plus 7 all over 21, which is equals to 12 over 21. Okay? And if you want to simplify further, this one, 3 here 4, 3 here 7, which is equals to 4 over 7. Okay? So another thing you can do is, first of all, you find that what? It is 8. That it is 8, that is 9 over 21. 9 over 21, it means this is for 8. Not 8, you remove it from 1. Remember, success plus failure equals to 1. So this will give us 21, 21, 9 equals to 12 over 21. Just like this. Then you can simplify to have 4 over 7. Okay? In this class, we're going to look at the addition rule. Addition rule. Okay? Addition rule. What is addition rule? The addition rule is a basic principle in probability theory. Okay? It's a basic what? Principle. It states that the probability of 2 events A and B occurring together is equal to the sum of their individual probability minus the probability of both events occurring at the same time. This addition rule is a basic principle in probability. Okay? It is divided into 2 types. That is, the mutually exclusive event and the non-mutually exclusive event. Okay? So what is the difference between these two? When we say 2 events are mutually exclusive, we are saying the 2 events, they cannot occur together. They cannot occur at the same time. Okay? Why this can occur at the same time? Let's look at the theory behind this. So you can see in this place, mutually exclusive event. These are events, okay, that cannot occur together. The additional rule for mutually exclusive events states that the probability of either event occurring is equal to the sum of their individual probabilities. Mathematically, this can be expressed as A or B, that is, this and this are mutually exclusive. Remember, this, as I've said before, is stand for or. We are looking at a situation like this where there is a disjoint between A and B. That is, they don't have anything in common. Okay? Nothing in common. For example, rolling a dice. Suppose you roll a 6-sided dice. The events of rolling an even number, okay, and rolling an odd number are mutually exclusive. They cannot happen at the same time. A die has these sides with these numbers. If you roll a die, one of these will appear. You can't have 2 and 3 at the same time. It's not possible. Either what will come out to be an odd number or what will come out to be an even number. Okay? So it is not possible to roll a number that is both even and odd at the same time. Flipping a coin. Consider flipping a coin. The events of getting a head and getting a tail are mutually exclusive. Okay? It is not possible to get both heads and tails at the same time. Okay? Choosing a card from a deck. Suppose you draw a card from a standard deck of 52 cards. The events of drawing a red card and drawing a black card are mutually exclusive. It is not possible, totally impossible, to draw a card that is both red and black at the same time. These are called mutually exclusive events. Look at this question. It says, in a restaurant, there are 2 types of desserts available, cake and ice cream. A customer can only choose one dessert. If the probability of choosing cake is 0.4, what is the probability of choosing ice cream? Okay? The probability of choosing a cake plus the probability of choosing ice cream is equal to 1. Okay? They are mutually exclusive. Therefore, if we have that of cake as 0.4, we are looking for that of ice cream, you know what to do. Okay? So, probability of that of ice cream is equals to 1 minus 0.4, which is equals to 0.6. You agree with me? We have seen questions like this. We have actually seen this type of question before now. But this time, we want to emphasize on the meaning of mutually exclusive. Okay? A college student can either major in engineering, business, or humanities. The probability of majoring in engineering is 0.4. And the probability of majoring in business is 0.35. What is the probability of majoring in humanity? We are going to use H to represent this, E to represent this, B to represent this. So therefore, the probability of this plus the probability of B, the probability of H, all equal to 1. If we have that of engineering as 0.4 and that of business as 0.35, we can actually find that of what? Humanities. By saying this is equals to 1 minus 0.4 minus 0.35. And if you solve this out, you're going to have 0.25. 2 fair-sided dice are rolled. What is the probability that the sum of the numbers rolled is either 7 or 11? Okay, I'm going to use a table for this. We put 1, 2, 3, 4, 5, 6 here. 1, 2, 3, 4, 5, 6. Okay, then we're going to do sum here. That is 2, 3, 4, 5, 6, 7. That's we are adding like this. This is 3, 4, 5. Okay? With this knowledge, let's map out 7. They are either 7 or 11. Okay? First of all, how many altogether? That is 6 multiplied by 6. That is 36. How many 7? 1, 2, 3, 4, 5, 6. Or 11. 1, 2. Okay? Give us 8 over 36. We're going to have 2 over 9. Okay? Look at this. It says in a classroom, there are students divided into 3 groups. Group 1 has 5 students. Okay. Let's see total students. That is 5 plus. Group 2 has 18. And group 3 has 12. If you add this together, you're going to have 35. Okay? It says if a student is randomly selected from the classroom, what is the probability that the student selected belongs to group 2 or group 3? Okay? That is 18 over 35 plus 12 over 35. To work this out now, 18 plus 12, going to have 30 over 35. 5 here will give you 6. 5 here will give you 7. Therefore, this is 6 over 7. Okay? Hope you understand this. A school has 50 students divided into 3 groups. Group 1 has 50 students. Group 2 has 20 students. And group 3 has 15 students. Altogether, we have 50 students. The table below shows the number of students in each group by gender. What is the probability of selecting a male student either from group 2 or group 3? Pause the video, work on it before we continue. Okay? The first thing we need to do, we look at the group we are looking at. This is a group we are looking at. Okay? We are actually looking at what? The male student. That is this and this. So, for group 2, that is 12 over 50. 3, 7 over 50. 50 here, 12 plus 7 equals to 90 over 50. Okay? So, this is the answer. That is 90 over 50. Okay? Look at this. The table below gives the mark score by group of students in a test. What is the probability of selecting a student from the group that scored 2 or 3? The probability of selecting a student from the group that scored 2 or 3. The first thing we need to do here is to first of all get the summation of what? The frequency, sigma f. It's equals to, this is 3, 10, 15, 19, 22. Okay? The next thing we need to do now is to look at the first one, that is 2. For 2, we are looking at this. For 3, we are looking at this. Therefore, it's going to be 7 over 22 plus 5 over 22. Going to have 12 over 22. This is 6. This is 11. Therefore, the final answer is 6 over 11. Okay? Let's look at this. It says a number is chosen at random from the set 15, 16, 17 to 32. What is the probability that the chosen number is a multiple of 7 or a prime number or a prime number or a multiple of 7? Okay, all the numbers that are involved are 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Okay? These are all the numbers. Okay? So if you count now, you're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There are 18 all together. So the total is 18. Where S is all these numbers. Okay? Now, multiple of 7. 21 is one of it. Okay? 28 is among. Okay? That is all. Therefore, the probability that it's going to be multiple of 7 is equals to 2 over 18, which is 1 here, 9 here, equals to 1 over 9. That is that one. Therefore, prime numbers, this is a prime number, this is a prime number, a prime number, a prime number, and a prime number. 1, 2, 3, 4, 5. So the probability that is going to be prime number is equals to 5 over 18. Now, the probability that is going to be either prime or a multiple of 7 is simply, probability is going to be prime or multiple of 7 is going to be 1 over 9 plus 5 over 18. Okay, that is 18, 2 plus 5 equals to 7 over 18. Okay? Now, let's look at non-mutually exclusive. Non-mutually exclusive events. These are events that can occur together. The additional rule for non-mutually exclusive events states that the probability of either event occurring is equal to the sum of their individual probability minus the probability of both events occurring together. Mathematically, all you have to do is the probability of A plus B, then you what? Remove what? The intersection. That is to say, there is something that brings them together. Something here brought them together. So if you want to find them now, you need to remove what is common between them. That is the and. If this is A and this is B, we are removing this part, that is minus this part, to have this and this for what? For the exclusive. Okay? So both events, they share something in common. That is to say, A intersect B is not equals to empty. That is, it's not empty. For the mutually exclusive, the one we had before, A intersect B is equals to empty. There is nothing that brings them together. Put that at the back of your mind. Remember, this in essence simply means this, A union B. Okay? For all of them. For the mutually exclusive, the intersection of A and B is equals to nothing. Why for this cannot be empty? Okay? Cannot be empty. This one is empty, but this cannot be empty. That is, this is non-mutually exclusive. This is mutually exclusive. Okay? For instance, rolling a dice. Suppose you roll a 6-sided dice. Okay? The events of rolling an even number and rolling a number greater than 4 are non-mutually exclusive. Okay? It is possible to roll a number that is both even and greater than 4 at the same time, such as 6. So you can see, if you roll it, if you have 6, that means 6 is even and 6 is greater than 4. Assume that's what you are looking for. You are looking for the probability of something that is even and also greater than 4. Definitely, that is 6. Okay? This one means what? Non-mutually exclusive. Non-mutually exclusive. There's something that brings them together. If the non is not there, that means nothing brings them together. That is, at least there's something that is connecting them together. Flipping a coin. Consider flipping a coin. The events of getting a head and getting a tail are non-mutually exclusive. It is possible to get both heads and tails if the coin lands on its edge. Okay? That is, if it lands on its edge like this, lands like this on the floor, you can have both. Another thing is drawing cards from a deck. Suppose you draw a card from a standard deck of 52 cards. The events of drawing a face and drawing a spade are non-mutually exclusive. It is possible to draw a card that is both a face and a spade, such as the king of spades. Okay? Now let's look at this question. A survey conducted in a school found that 60% of the students participate in sports, 50% participate in arts, and 20% participate in both sport and arts. What is the probability that a randomly chosen student participate in either sport or arts? Remember, this is taking us back to set theory. If you remember set theory very well, assume we are looking at these two. We are saying sport and arts, okay? Sport and arts, sport and arts, okay? 50% in art, 20% in sport. Here becomes X, okay? If here is S, to get this part now, say 20 minus X. To get this part now, say 50 minus X, okay? What is the probability of randomly choosing a student that participates in either sport or this? Okay? So in essence, what we are saying is the probability of sport union art is equals to sport plus art minus sport intersect art. The probability that is sport is what? Is 60. That of art is 50. The intersection is 20. That is all. That is 110 minus 20, which is equals to 90. Okay? That is 90%. Or you can call this 0.9. Okay? Out of 200 people attending a conference, 120 prefer coffee, 80 prefer tea, and 40 prefer both coffee and tea. What is the probability that a randomly choosing attendee prefers either coffee or tea? Okay? That is, we are looking at coffee or tea. That is coffee plus tea minus coffee intersect tea. So what is the probability of coffee? Probability of coffee is 120 all over 200. That is 120 over 200. For tea is 80 over 200. Why this is what? 40 over 200. Okay, with this now we are good to go. Come to this place to have altogether 200, 120 plus 80 minus 40. You're going to have 200 minus 40, that is 160 over 200. This and this will go 4 here, going to have 4, 4 here, going to have 5. That is 4 over 5. Okay? Look at this. In a class of 35 students, 50 students are taking English and 10 students are taking history. There are 5 students taking both English and history. What is the probability that a randomly chosen student is taking either English or history? Okay, a randomly chosen student is taking either English or history. So to get this, we're going to do probability of English union history is equals to English plus history minus English intersect history. Okay, this is equals to, for English is 10, that is 10 over the total, that is 25. For history is, English is 15. Why this is what? 10. Both is 5. Okay? So this is equal to 25. 15 plus 10 minus 5 equals to 25 minus 5. Don't need to do this. Just put 20 over 25, which is equal to 4 over 5. Okay? Look at it. It says if an event A implies obtaining prime number and event B implies obtaining odd number in a single throw of a die, find the probability of A or B. Okay? Probability of A union B is equals to A plus B, A intercept B. Okay? For A, event A, which is prime number, less the die sample space that is the die sample space. Okay, so for this first one, we are looking at what? Prime numbers, which are this and this. Okay, y for the odd are this and this. Okay, so let's see. Altogether for prime, 3 over 6. For odd is 3 over 6. Then the intersection, as you can see in this place, we have two intersections. That is this and this. That is 2 over 6. You agree with me? We're going to have 6 here. We're going to have 6 minus 2, which is what? 4 over 6. Okay? Therefore, finally, we're going to have 2 over 3. This is the final answer. There are 12 cards, number 1 to 12. A card is selected at random. What is the probability that it is either even or perfect square? Okay, perfect square. Let's put down the sample space. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, let's use the yellow for even. Okay, I'm going to use white for perfect square. This is a perfect square. This is a perfect square. But the issue is that there's intersection. That is this 4. 4 is both even and also a perfect square. Therefore, let's calculate now. I'm going to use even union perfect square is equals to even plus perfect square minus even intercept perfect square. Okay? Therefore, for even we have 1, 2, 3, 4, 5, 6. 6 over 12. Y for perfect square, 2 over 12. Y for the intersection is 1 over 12. Okay? This is 1 over 12. 2 over 12. 6 over 12. Okay? If we work on this now, 6 plus 2 minus 1. That is giving us 7 over 12. Okay? 7 over 12. Let's look at this. It says a box contains 40 numbers from 1 to 40 inclusive. What is the probability of randomly selecting a number that is either a prime number or a multiple of 5? Okay? Let's get the sample space. You must not write it down like this. It's not needed. We can actually remove everything here, make it simple. Let's concentrate on the sample space for prime numbers between 1 and 40. So for these prime numbers, let's say that is prime. We are looking at the cardinality of prime is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. Okay? Let's now get for multiple of 5. Of 5. That is 5, 10, 15, 20, 25, 30, 35, 40. Okay? Because we are told that 40 is inclusive. 1, 2, 3, 4, 5, 6, 7, 8. Okay? We have 8 altogether. So the cardinality of multiple of 5 is equals to 8. So the next thing you need to look at now, is there any intersection? I can see one intersection because this is 5, this intersection. Any other intersection? No. No any other intersection. Therefore, we are going to say the probability of prime number union, let's say multiple of 5, let's just put 5 here, is equals to the probability of prime multiple of 5 minus prime intersect multiple of 5. Going to have here now 12 over 40 plus 8 over 40 minus 1 over 40. Okay, we work on this now. Going to have 40 here, 12 plus 8 minus 1. Okay, and you agree with me, you're going to have 90 over 40. Okay, this is the final answer, okay, for this question. So with this, I believe you understand the non-mutually exclusive event. Okay, in this class we're going to look at multiplication rule. Okay, multiplication rule. Okay, what is multiplication rule? The multiplication rule is a fundamental concept probability theory that helps you find the probability of 2 or more events occurring together. Okay, there are 2 versions of the multiplication rule, depending on whether the events are independent or dependent. Okay, in this rule we have this, that is and both. What are independent events? 2 events are said to be independent if the occurrence or non-occurrence of one event does not affect the occurrence or non-occurrence of the other event. In other words, the probability of one event happening does not change based on whether or not the other event has what occurred. Okay, what about dependent events? 2 events are dependent if the occurrence or non-occurrence of one event affects the occurrence or non-occurrence of the other event. In other words, the probability of one event happening changes based on whether or not the other event has occurred. Okay? For example, for independent event, tossing a coin twice, the outcome of the first coin toss does not affect the outcome of the second coin toss. For dependent event, drawing 2 marbles from a bag without replacement, the outcome of the first draw affects the probability of the second draw, since there is one less marble in the bag. Okay, remember, when you are doing anything like draw, like if you have say 10 marbles in this bag, for instance, you pick the first one, definitely you're going to say 1 over 10. If you are drawing the second one now, you will do 1 over 9. As you can see, the probability of this one is not affecting this denominator. So this second draw is being affected by the first draw. Okay? Another example is rolling 2 dice simultaneously for independent event. The outcome of one die does not affect the outcome of the other die. For dependent event, drawing 2 cards from a deck without replacement. One thing you will notice about dependent event is issue of what? Not replaced or without replacement. The outcome of the first card drawn affects the probability of the second card drawn, since there are fewer cards left in the deck. Okay. Another example for independent event: 2 factories produce items independently of each other. Okay. The number of items produced in factory A does not affect the number of items produced in factory B. Okay. Lastly, dependent event: the number of students enrolled in a chemistry class affect the number of students enrolled in the chemistry lab, since students must enroll in both the class and the lab concurrently. Okay. When it comes to dependent event, you have 2 probability. So you can see we are using and. You have to multiply the probability of the first one by the probability of the second one. You can read it as probability of A multiplied by the probability of B. Okay? For this second one, that is dependent event is the probability of A multiplied by the probability of B. We should have stopped here. So you can see we continue with another thing here entirely. What is this all about? It's saying the probability of B given that the probability of A has occurred. A has occurred, right? Multiplied by the probability of B. This is considering that this B is being affected by A. This one is saying, put it at the back of your mind that the probability of B is being affected by the probability of A that has already occurred. Okay? So we read this bar or pipe like this. That is, given that the probability of A has occurred. So you can see probability of A multiplied by probability of B given that the probability of A has occurred. Okay? Because it is talking about what? Dependent event. Now, let's look at this question. 3 balls are drawn successfully from a box containing 8 red balls, 6 white balls, and 4 black balls. Find the probability that they are drawn in order of red, white, and black if each ball is replaced. With this statement now replaced, it means the next probability will not be affected by the previous probability. Independent event. Okay? Now, we have a box. This box has 8 red, 6 white, and 4 black. Now, the first one that was drawn happens to be what? Red. How many red altogether? We have 8 red in the box. Total is 18 balls altogether. So because the first one is red, we take this 8 to represent all the red, all over 18. Multiply by, the next one was white. So the white will represent their group, that is all the white will be taken, all over 18. Multiply by 4 over 18. Okay? You agree with me now that 6 here is 1, 6 here is 3. 2 here is 2, 2 here is 9. 2 here is 1, 2 here is 9. This multiplied by this 8. Why the denominator will give us 243. Okay? This is the answer. Because there was replacement, the denominator remains the same. Okay? A box contains 2 red balls and 4 blue balls. A ball is drawn at random from the box and then replaced before a second ball is drawn. Find the probability of drawing 2 red balls. So you can see there's still replacement. It means it's what? Independent event. Okay? So, to get the probability, we have in the box 2 red. So you can see 4 blue. Okay? Find the probability of drawing 2 red. Okay? The total here is 6 balls. But it says a ball, 1 ball is drawn. That is 1, just 1. We are talking about now 2 red are drawn. So the first one that was drawn happens to be red. That is 2 representing reds all over 6. Again, you draw, you still have what? Red. Remember there was replacement. So the red were not reduced. That is 2 over 6. So the next thing we need to do now, 1 is here, 3, that's equals to 1 over 9, okay? A pair, that is 2, of fair dice with each face, number 1 to 6, are thrown once, okay? Find the probability of scoring a 2 on one die and a 5 on the other die, okay? We have 2 of them. You took the 2, you throw. What is happening here does not affect what will happen here. What is going to happen here will not affect what will happen in this place. They are independent events. The question is now saying, find the probability of scoring 2 here and 5 on this other side. Okay? I remember that this 2 is just like a label for that face. So it's only one face that is shown to you out of 6 faces, or one face is shown to you out of 6 faces. So the probability is for this is 1 over 6 multiplied by this 1 over 6, which is equals to 1 over 36, because they are what? Independent events. Look at this. A bag contains 3 black balls and 2 red balls. A ball is picked at random from the bag and then replaced. A second ball is chosen at random. What is the probability that 1, they are both black, 2, one is black and the other one is red? These 2 altogether 5. For this one, the first one is black, that is 3 over 5. The second one is also what? Black. That is again 3 over 5. There was replacement, okay? Therefore, we have for the first one 9 over 25. For this one is black, the other one is red. That is 3 over 5 for the first black. The second one is red. That is 2 over 5. Therefore, this is equal to 6 over 25. Let's look at this. It says 2 first 6-sided dice are rolled. What is the probability of getting a sum of 7? If you roll 2 dice, what will happen in the first die will not affect the second die. Okay? Now we are told that 2 are rolled, but we need summation of 7. It means we are going to evolve table. So 1, 2, 3, 4, 5, 6. Also 1, 2, 3, 4, 5, 6. Okay, this is sum. That is 2, 3, 4, 5, 6, 7. This 3, 4, 5, 6, 7, 8. Okay, this is what we are talking about. 1, 2, 3, 4, 5, 6. That is 6 over 36. 6 here 1, 6 here 6. That is 1 over 6. Okay? You toss a fair coin 3 times. What is the probability of getting exactly 2 heads? Okay? That is, this is coin 1, coin 2, coin 3. Okay? So you have head here, you have head here, you have head here. Head, head, tail. Head, tail, head. Okay? Tail, head, head. Head, tail, tail. Tail, head, tail. Tail, tail, head. Lastly, tail, tail, tail. Tail, tail, tail. Okay? The question says, what is the probability of getting exactly 2 heads? 2 heads. Exactly 2 heads. So you agree with me, this is head, head. Exactly 2 head. This one is okay. This one is okay. This one is okay. That is all. Exactly 2 heads. That is 3. Altogether we have how many? 1, 2, 3, 4, 5, 6, 7, 8. That is 3 over 8. Okay? Next is this. A bag contains 4 red balls and 6 green balls. If you draw 2 balls with replacement, what is the probability of getting one red and one green? I want to leave this one for you to do. This one is straightforward, okay? Look at this one too. A first six-sided die is rolled and a fair coin is flipped. What is the probability of an even number on the die are getting a tail on the coin flip? Okay? What we're going to do, 1, 2, 3, 4, 5, 6 for the die. This is for the coin, that is head and tail. Okay? So the question says, what is the probability of rolling an even number on the die and what? Getting a tail on the coin. For me, if you ask me to do this, I will just follow the tail. Tail. Okay? Then I will concentrate on the even numbers. That is, this one is even. That is 2. This is even. That is 4. This is tail 2. That is 6. That is all. I will avoid the odd number. This one is out of it. You are out of it. You are out of it. Okay? How many? 1, 2, 3. Altogether is 2 times 6. That is 12. That is 3 over 12, which is 1 over 4. You can still fill this one up. The reason why I did not fill it up because we are not looking at heads. We are looking at tail. For this other one that are odd numbers, I avoided them because we are not looking for odd numbers. Okay? But if you want to fill it up altogether, there's no problem. This one says a bag contains 9 identical birds, out of which 3 are blue, 2 are white, and the remaining are red. If 2 balls are drawn at random, one after the other, what is the probability that both of them will be red if there is no replacement? Okay? Now, let's look at it. In the bag we have here, altogether 9 balls. Okay, 9 identical balls. We have for blue, 3 blue, 2 white. The remaining ones are red. That is, we have 4 red. So the question says, what is the probability that both of them will be red? Okay, no problem. Now we have 4 red. So for the first attempt, we have 4 altogether, all over 9. Once we remove 1 from this 4, it will now remain 3 red for the second draw because there's no replacement. So this is dependent event. So what is the total if you remove 1 here the first time? It will remain 8. 8 altogether. Here's 1, 2, 1, 3. That is equals to 1 over 6. Okay? And remember, if this is probability of A and this is probability of B, you have to say probability of B given that A has occurred. That is, this multiplied by B given that A has occurred. Because it's the occurrence of A that is affecting this denominator and also affecting this numerator. Okay? Let's look at this. It says a bag contains 5 red balls and 7 green balls. You draw 2 balls without replacement. What is the probability of drawing 1 red ball and 1 green ball? This is trickish. I would like you to pause the video and work on this before you look at the solution. Very important. There's a reason for that. Okay, I believe you have done that. As you can see, this question did not tell us that the first one that was drawn is red or green. We don't know the one that was drawn first, if it was the red or the green. So because of that, we are going to look at 2 scenarios. The first scenario is red was drawn first, then blue. The second one is blue first, then red. So it means this becomes the probability of red and blue is equals to probability of red multiplied by the probability of blue given that red has occurred. Why this one too is the probability of blue and red is equals to the probability of blue multiplied by the probability of red given that blue has what occurred. As you can see, when it comes to dependent event, you have to look at the wording, the way the question is what framed. Otherwise, you miss it. This is not independent. Independent, you can just go ahead and do. But if they have told us that red was first drawn before green, we will not have two considerations. But because of the way the question is opened, we're going to do all, either this or this. So, to work on this now, the total is what? 12. So total here is 12. Red is 5. Blue is 7. Total here is 12. Red is 5. Blue is 7. So if we come to this place now, I want to use this place to work on this as equal to red first, that is 5 over 12 multiplied by 7 over 11. Because when you remove red, the total reduced. If you come to this second attempt, that is blue first over 12 multiplied by red over 11. Okay, so if you work on this, I'm going to have 35 over 132. The same thing with this, 35 over 132. So you have to add the two together. That is 35 over 132 plus 35 over 132. Why are we adding them together? Because we are considering either this or this. The or is the plus. Okay? That is 132, 35 plus 35 equals to 70 over 132. So 2 here is 35. 2 here is 66. So the final answer now is over 66. Okay? In a box of 10 light bulbs, 3 are defective. If you randomly select 2 bulbs without replacement, what is the probability that both bulbs are defective? Out of the 10, 7 are good, 3 are defective. Okay? Altogether, we have 10. If randomly selected, what is the probability that both bulbs are defective? This is straightforward. We can't miss it. Okay, with this now, we look at the first one, 3 over 10. Once you remove 1 defective, remains 2 defective now. But the total will be affected. Take it to what? 9. Okay, 1 over 15. A school has 8 male teachers and 12 female teachers. If you randomly select 2 teachers without replacement, what is the probability that both teachers are female? So 8 male, 12 female. Altogether, we have 20. We are told that both are same sex. That makes it easy. So we're going to have 12 over 20 multiplied by 11 over 19. If you multiply this now, you have 132 all over 380. And if you reduce further, you're going to have 33 over 95. Okay, 95, 33, 95. Okay?